So I know this is going to look like a lot of information right here and lots of words, but this top section here, this is the section that's just giving you information about the problem. And then the star right here, that's where you're starting the problem. So there's kind of two parts to the problem. This is kind of like part A, and this is like part B. So we have a reaction. It begins with only reactants. Once equilibrium is established, the constant at that temperature was determined to be this value. So we don't have to calculate it. It already is. So here's our reaction. And then we would say Kc is 0.877. And I probably should have indicated that it was a Kc equilibrium. All right, so it's repeated with these other numbers. So notice I've got a value for the H2 on the bottom, the I2 on the bottom. Oh, and this is supposed to be HI on top. So we just have some new numbers. So we want to know, when we mix them all up, like that first initial bit of moment where they're starting to mix, we're going to see where we are with respect to the equilibrium. Like, you'll see what I'm saying in just a second. So QC, Q is the same as K. It's that same relationship. It's just that Q is at some point that's not equilibrium. So it's still that HI squared. And remember the squares because there's a 2 in front. Over I2 times H2. And we're going to get a number here, and then we're going to compare it to this number. So I'm just going to plug my numbers in. 0.416 squared divided by I2 is 0.567 times 1.01. That's all on the bottom. So now I'm going to bring over my calculator. And I have 0.416 squared divided by 0.567 and divided by 1.01. If you just want one divided by sign, you're going to have a parentheses on that bottom section. So I get that the Q value here is 0.302. Now, because I'm trying to be consistent, I'm actually also going to work the next part of the problem, and we'll do the comparison at the same time. So now we have a different set of amounts. So it's the same Q. So this same equation here. And now, this is also HI. I'm going to put 0.810 squared. It's real easy to lose exponents, so be careful with them. Times 0.348 times 0.567. So 0.810 squared divided by 0.348 and divided by 0.567. And in that case, I get 3.325. Now, when I do that comparison, I'm going to compare K first to Q. Now, most people do it the other way, all right? But I feel like if you write it alphabetically, it is helpful. And so I'm going to say when I compare the two of these, if K is 0.877 and Q is 0.302, then K is larger. And then again, if K is 0.877 and Q is 3.325, then Q is larger. This tells me which way the equilibrium is going to shift. Because you'll notice I started with some product in there. So do I have more product? Is it mostly going to want to go reactants or what? No. What this is saying is that I have more reactants and they need to get used up to reach equilibrium. And in this case, what it means is that I have more products and they are going to be used up so that I can reach equilibrium. So I'm basically going to be generating reactants is what I'm doing. In this top case, I'm generating products. The bottom case, I'm generating reactants. And just do a quick look at the information difference. So this is where our product is right here and right here. Does it make sense that this one has more product? Just look at that number. So those are some ideas also to kind of think about.